What's up, guys? Welcome back to another Algebra 2 instruction lesson here with Mr. Gaines as we continue our discussion on Unit 9, which was function operations. We are starting a new section today, and this section is over one-to-one and inverse functions. We're actually going to start by looking at one-to-one functions and with a discovery activity. So if you have printed the notes, go ahead and see if you can complete problems 1 and 2. I'll put them up here on the, just problem 1. I'll put it up here on the screen so that you can see problem number 1 if you haven't finished or printed the notes. But go ahead and pause the video for a moment and complete problem number 1. Okay, hopefully you guys had a chance to go over problem number 1, take a look at problem number 1. Here we are taking a look at the definition of a one-to-one function. And what we're going to do to come up with the definition of a one-to-one function is we're going to consider two simple functions. F of x, which has a function of, is defined as 2x, and g of x, which is defined as x squared. And in part A, it says to fill in the range values for each function that map with the domain of -2, 0, and 2. So if I were to essentially substitute -2 into f of x, that would be -2 times 2, which would give me a result, an output, or a range value of -4. If I were to take 0 and substitute it into f of x, it would give me an output of 0. And if I were to take 2 as an input of f of x, it would give me an output of 4. Taking the same numbers for g of x, I'm going to notice my range is going to look slightly different. -2 as an input to g of x, -2 squared would give me a positive 4. 0 as an input, 0 squared would give me 0. And 2 as an input, 2 squared would give me the output 4. So in part B, it says, of the two functions, f of x would be considered one-to-one, while g of x would not. Use results from part A to hypothesize a definition of a one-to-one function. Well, we know what a function is. We know a function as a expression where each value of the domain will map to only one value in the range. So the domain, each x value has one y value. To be a one-to-one function, the converse of that has to be true. So each y value is only going to have one x value. So if we look at f of x is actually a one-to-one function because each of the x's go to only one place on the y, but each of the y's also go to only one place on the x. G of x would not be considered one-to-one. It is a function because each of the x values only go to one y. However, one of the y's goes to two x values. One of the range values goes to two domains. So this is not one-to-one. A one-to-one function can be defined as a function in which each range value maps to one domain. So because it's a function, we know the domain goes to only one range. Each x goes to one y. Now to be one-to-one, the converse again has to be true. Each y goes to one x. So let's take a look at some examples of problems that ask about the domain, the definition of a one-to-one function. So in problem number 2, it says of the four tables below, one represents a relationship where y is a one-to-one function of x. Determine which it is and explain why the others are not. So if we take a look at the table, basically we can go through and first identify which one is going to be the one-to-one function. And at the same time, let's go ahead and rule out why the others could not. So if I take a look at problem number 2 here, or table number to letter A, I'll notice that there are x's going to multiple y's. So initially, we can identify that there's a problem with this table. This is not a function. It's not a function because it has x values that go to more than one y. So if it's not a function, it cannot be a one-to-one function. Let's take a look at B. B, here I look at all of the x's are going to one y. However, I see a y value that is repeated. Y value of 1 is repeated. So 1 on the y value is going to -2, and 1 in the y is also going to 0 on the x value. So this has, let's say this has a y value. Actually, let's say y equals 1 maps to more than 1 x value. So though this one is a function, all of the x values map to only one y, it is not a one-to-one function because the y value 1 breaks the pattern to be one-to-one. It maps in multiple places. If I take a look at C, it does pass the function test. Each of the x's has a different y value or only one y value. And then if I look at the y values, none of them are repeated. They all go to only one x value. So I could say that C is a one-to-one function. So C would be the only one here. It did say that there was one, and now we have identified it. C would be the only function that is one-to-one. Now let's look at D and see if you can figure out why D is not a function. If you said, or sorry, not a one-to-one function, I guess I just gave you the answer. If you said it is not a function, then you are correct. So in this case, each x value does not map to only one y. We see -2 that goes to 9 and -2 on the x value that goes to 10. So the first thing that you'd want to check is it a function? In this case, no, it's not. If you also check the y values, you'd see the y value equals 10 maps to more than one x value. Problem number 3, we're given graphs now and we have to determine which is a one-to-one function. So first thing that we would have to do is see if it is a function at all. So what we can see, we can identify here that graph number 2 is not a function. Remember, we have this vertical line test. And in order to pass the vertical line test, a function must only have one x value or one y value for every x. And I can see here with the vertical line that in this position right here, the function or the graph shown in problem number 2 has 4 y values to one x. So this is not a function. So we can get rid of number 2 here. This one's not a function. And if we take a look now at 1, 3, and 4, those are all functions. So far, so good. Or sorry, mistake there. Hopefully you caught that, is number 3 a function? Your answer should have been no, not a function, because this one as well does not pass the vertical line test. So out of 1 and 4, those are both functions. Which one is one-to-one? If you said 4, you would be correct. Visually, graphically, along with the vertical line test compares x values to one y value. We could do a horizontal line test. A horizontal line test will tell you how many how many x values there are to a single y value. So let's say we use the x-axis as my horizontal line. I can see that there are 2 y values for that single, 2 x values for that single y of y equals 0. So 1 is not a one-to-one function. Problem 4, or graph 4, however, is one-to-one. So it passes both the horizontal and vertical line tests. So if we wanted to explain that answer, you could go a couple of different directions here. We could talk about the testing of the line, the horizontal line and vertical line test. So number 4 passes both the vertical line, and we'll say that's determining a function, and horizontal line tests. And the horizontal line test here would determine if it is one-to-one. So in order to be one-to-one, it must pass both a vertical line test, which we've seen earlier this year, and a horizontal line test. You could also could explain something along the lines of saying that number 4 here is the only one-to-one function because it is the only function where each y value maps to only one x value, or each range value maps to only one domain value. So first we check to see if it's a function. We can do that with a vertical line test, and then checks to see if it's one-to-one. We can do that with a horizontal line test. So this gives us a basic concept of one-to-one functions. The definition that we came up with is a function, first checking to see if it's a function, where each range value maps to one domain value. These are special types of functions which are actually going to set us up as we progress in the future to exponential and logarithmic functions. At this point, this is a good place for us to stop. So when we get back into class, we'll be able to discuss this definition, look at some more examples, and then continue with some practice. As always, guys, thank you guys for tuning in, and I'll see you soon.